Here we have what's called weighted alpha, which is a measure of risk-adjusted performance over stocks for over a period of time. And we have one for the 30 highest stocks in the Northeast versus the West. And we just want to see, is there sufficient evidence of a difference in weighted alpha? So if we're just trying to see a difference, again, that's exactly what our two-sample procedures does. And so we're going to perform a test to see, is there a difference, not make an estimate. So let's go through our 5 steps and see how this pans out. So our first step is make sure we just know what we're talking about, plus putting together our hypotheses. So we'll let this mu and e represent the mean weighted alpha for Northeast. And likewise, we'll let mu w be the mean weighted alpha for the West. And of course, we're going to write our hypotheses. So we have the null and our alternative. So putting this together, if we're just trying to find a difference, that means we're going to assume again that there is no difference, as we always do for these two sample stuff. We're going to say the Northeast minus the West is 0. Since they are the same, they have a difference of 0. However, we're just trying to see, is there a difference, not if one is higher or lower than the other. So when we write this one out, we're going to use a not equal to, a two-sided alternative here. Now we are working with quantitative data, which gives us the means. And so what we know is the means will always be working with t. So we're going to use a two-sample t test. So checking the conditions, yes, we can take the time to check the independence and the random. We're assuming that these two things are completely independent from each other. Random, they're not necessarily random, but hopefully that these companies' values that we do collect are representative of the values of these companies at any given time. So we're not going to write anything for that for right now, but we will focus on just making sure we always check that large enough, which is one of the most important. And we do find that both cases, we have n is 30 here and n is 30 here. And that's our minimums for this class. So we'll say, okay, both samples have n equals 30, which is at least 30. So we're good to go. Now that we have that stuff out of the way, let's get to our 4th step, which is, of course, the calculations, which we will use technology. And again, my choice of technology is going to be StatCrunch, but if you choose to use something else, that is completely your option. So on StatCrunch, I need to type in each of these data sets in here and into single columns, not multiple columns like this. And I've already taken the time to do that. So here is the data set. So I have the 30 values for Northeast and the 30 values for the West. So as you might expect, we're going to go to stat, tstats, to sample. And again, now that's different is we actually have the list of data, the actual numbers. So we're going to go with data rather than with summary. And here's how it works. We're going to choose one sample, choose the column with the second sample. Again, we'll leave pooled variances turned off since we're not going to make that assumption. And we already have our hypotheses matching what we've written before. Just make sure that, again, everything matches. Since in my hypothesis, the order, I put Northeast first and then West second. Well, I typed in Northeast first. It's going to represent my mu1. And second is going to be my West. And now we do compute. So it gives us all this information that we have. For example, the difference in the sample means, the sample difference. It even tells us like the degrees of freedom and standard error if we needed to do this by hand. But the two things that we are looking at is, again, the test statistic and the p-value. So we have our test statistic and the p-value. So let's get those two things. Our test statistic is 0.153, and it's a t-test statistic. Does not sound very big. And our p-value was 0.8787. So that's a very high p-value. So finally, let's make our conclusion by comparing that p-value to our level of significance. It doesn't state, so we'll just use our standard alpha is 0.05 when it doesn't give it to us. So in this case, we can just follow our standard sentence again. Since the p-value is greater than 0.05, again, when it's greater, we fail to reject H0. A high p-value is not very much evidence. So we fail to do this since it's not much evidence. So what does this mean? There is insufficient evidence or not enough evidence to show. And what are we trying to show? Again, the alternative, which is saying that they're not equal, that there is a difference between the weighted alphas in these two regions. So there's not enough evidence to show that. There we go. Not enough evidence to show a difference in weighted alpha between the two regions.